Okay, good evening, everyone. Welcome to this session. I can see there are 6 participants in the room already. So I think we are very much fit to start. Good evening, everyone. Please confirm you can hear me.
Yes, I can hear you. Good evening.
Thank you very much. Okay, so I'll start with a quick introduction. My name is Arin Zonyasibilem, and I'm your host for the Get Into Tech Bootcamp. Today we are going to be hosting 2 leading professionals in their field. So I'll start by reintroducing the purpose of this bootcamp. So this bootcamp, today's session is going to last for 1 hour, 15 minutes. It won't exceed that time. The purpose of the bootcamp is to help you find a purpose for which you should build a career in tech. So we have 2 presentations coming on, 15 minutes each. And after that, we have a 5 minutes long question and answer session during which we would entertain any of your questions. So today's session is focused on data and analytics, how it is helping businesses grow, how it is changing the world, changing the narrative around the world. And then the second presentation from Mr. Zion Ibobwe is on artificial intelligence and how it is impacting industry. So by their presentation, or what we call pep talk, we hope to inspire you or to enlighten you, help you see how these technologies or these fields are changing the world, changing the game across different sectors, industries, and organizations. We want to inspire you to want to start a career in those lines. So that's really the goal for today's session. So as you listen to those to their presentation, we hope you take note of your questions and then bring them back on board during the question and answer session. So before we hand over to them, any question on that? Okay. Yeah, so it's going to be 1 hour, approximately 1 hour, at worst 1 hour, 15 minutes. So okay, so Mr. Pascal is here. I will quickly hand over to him. Mr. Pascal is lead data analyst at Wapik Insurance. That's what's formerly called, known now as Coronation Insurance. Over to you, Mr. Pascal. I'll allow you to do your introductions yourself, just that different.
Hello and welcome, everybody. Welcome once more. My name is Pascal Chukwuemeka. I'm presuming we can hear me. Am I able to share my screen? Okay, I think so. I see the button.
Yes, you can share your screen.
All right. So, like Arinze pointed out, so I'm trying to share now. All right, so I'm Pascal Chukwuemeka. I hope you can see my screen. Arinze, can you see my screen?
Yes, you can see it.
All right, cool. So I'm going to speak today on how data is changing our world. Okay. I lead the data analytics unit of Coronation Insurance. We are formerly known as Wapik Insurance. I will make sure this stops 7:20 or before that. We are 7:05 now. So you probably know what you are looking at now. So let me not say much after that. Let me go to the next one. So this guy will want to be sure whether you are sure what you saw before, and then asking you, then what am I? Maybe I should go back one step again, and I'm hoping you figure what you're looking at. Then, and this guy too. So after that, I will say or put a question mark behind something I think most of us would have heard about data. So I'm presuming we have heard about data before. We pretty much can say 1 or 2 things about data. So data is the new oil. That's what we hear very often. Let's look at oil. It's so important that many things will not work without it. I mean, literally, it powers everything we do. From our houses powered by electricity to diesel-powered power plant, to diesel-powered power plant, yeah, to our cars, airplanes. Almost everything you look at has an imprint of oil on it, and you'll be wondering what we will do with that oil. So, and probably data is something like that. Let's see. So, what we just heard, as far as I'm concerned, would be true, say, 50 years ago, right? Much of it is still true today. But if you look today, we power our homes via other means like solar and wind energy. Even our cars today are driven without petrol or diesel, as they are now electric, right? They might not have come to Nigeria a lot, but today we know about Tesla and companies like that. So, and although we have Toyota, Mercedes, and all of them, and the rest of the cars that we know who still use diesel-powered engines, if you if you take a deeper look, you see that most car companies today are doing one project or the other around engines that are not powered by diesel. Okay, so we are going away from oil. And if they're all doing that, I've seen a prototype from Mercedes. Toyota has something, and so many of them. So it must be pointing towards something. So oil is still that critical, okay? Like decades ago. Would you agree to that? I would say that in as much as it still plays a great role today, and will still continue for a while, we are told, and we actually know because we are seeing it, that it's a matter of time, and not just time, but also the exigency of securing the planet, right? Because we keep hearing that climate change is a product of, um, the increasing temperatures around the world is a product of all the carbon we've been burning. So it's a matter of time, and the place of oil will gradually fall apart, and cleaner sources of power is going to take over, or are going to take over. Now, that drives every decision that we take. Okay, every entity, whether living or non-living. Remember the pictures I showed you at the beginning. The first thing that sometimes when you are asked, okay, so let's say you are in a class, somebody calls you up and says, 1 plus 1 is what? You immediately start asking yourself, has 1 plus 1 changed from 2 to some other thing like the previous night and you didn't get the memo or something? So yeah, I'm actually pretty sure you convince yourself those are 2 pictures of a goat. Now, how did you figure that out? Have you given it a thought? Okay, so I think data, unlike oil, is something we cannot find an alternative for. How do you know that thing is a goat? Have you seen a goat before? Of course. So you are probably working on a body of data that you have. And this is what we do on a daily basis, even when we are not conscious of it. So data is a component that we really cannot alternate with some other thing. It is not like oil. It's not. It will not get replaced. And I bet you it's going nowhere. What is actually happening is that we're only figuring out ways to harness it even more. Okay. You would have seen the graphic or the numbers quoted where it said that in 2010 we've produced more data. We produce more data on a daily basis than we ever produced in the whole history of humankind, right? So we are only trying to figure out ways to amass and harness more data so we can use them for decision making. So what best describes what we cannot survive without? It appears today is not oil. So I will tell you, you must have thought of it, is oxygen. So from realizing that you are reading something on a smart device now, okay, because you have taken in some data around you to figure it out. And I keep saying, even when you are not conscious of it, this is what we do on a daily basis. I mean, once we get up and start working, we're actually processing data and making decisions on the fly based on data that we have. Okay, so you figure out it's a smart device and it's not a chalkboard. You can make that distinction. So from that to an organization deciding on where to expand to, okay, are they expanding to Europe or the Middle East and North Africa? Okay, they're expanding from Europe to Middle East and North Africa. It is the data that they have about their situation that drive their awareness of things around them and also impacts heavily on the decision they are going to make. Okay, so I'm not going to say anything new today. Okay, anything you totally have not heard about, but I will tell you some stuff you have heard about, but are just not aware of it. So if you ask me, I will tell you that data is actually not it's not like oil. Okay, we cannot do without data, whether consciously or unconsciously. So I will call data the good old oxygen. That is what every one of us has to work with. And once you don't work with data, I mean, right from your basic decisions, like figuring out that that is a goat and not a dog, you are actually already starting to use data. Okay. So that said, let's go to the actual thing we are going to talk about. So how is data changing our world? And I want to rephrase it. Data may not actually be changing our world. I think data has already changed our world. It's a matter of how are we catching up to it. Okay. So since the business of data came into organizations' consciousness, it has never remained the same. I mean, organizations have practically changed. Yes, we can say data is still changing our world, but I want to argue that data has already changed our world, will continue changing is changing our world, and will continue changing our. Let's examine some of the ways this has been happening. And to do this, I'm not going to bore us with longer presentations. I'm going to take us to a link actually, because I think they very beautifully put it together. And the first link I'm going to go through with you, and the second one I will leave you to go through it later on your own. So the first link has actually three important aspects of how data is changing our world that I want us to look at. So I'm going to, okay, I think it's open here already. Now, it says three major ways data science is changing the world today. So whether you're calling it data, or you're calling it data science, we want to call it machine learning, anything around data, that is what we're talking about today. Now, it's very simple. We can predict the future. You know, sometimes you say, what's the big deal? The big deal is that today, like I pointed out earlier, a company is trying to diversify. They've been in Europe. Now they want to move out, and the decision is it Middle East or is it Africa? How can they do that? How can they predict that going into this place is going to do them better than going into the other place? It's just about the type of data that they have. So once we start amassing this data, I would have loved to, there is a graphic I would have wanted to show us, but it's something private, but I'm going to just talk through it. Now, as part of my day's job, analytics in where I work, there is a job we did looking at um, the possibility of customers defaulting on their payment. Okay. Now, um, it's not a loan product, it's just an insurance product that is paid every month. You know, the premium is paid monthly. Is a retail product. Now, you want the customers to keep paying, right? And is there a way for you to figure out that one customer or the other will stop paying at a point? Or are you able to figure out how many new customers are you going to get in 1 week or in 2 weeks, you know, or further down the line over a year? All these go into how management can actually make plans for expenses, plans for expansion, and so on and so forth. So with our data, we can now comfortably predict a number of things that is going to happen in future, of course, given the data that we have of things that happened in the past. So one of the ways data is changing what we are doing today is that we can more confidently say that this is going to happen in the future based on what we have seen happen in the past. Without data being harnessed, maybe what we will be doing today is just, gut decisions, guessing that this could work, guessing that that is going to work. So guessing that if we did our product to be X, Y, Z instead of A, B, C, maybe it could get more customers. But with the data we have today about our sales and data analysts and machine learning scientists working on it, we can actually figure out that ABC is going to sell more to a particular group of people than XYZ. So companies today are able to make that decision based on their data, and it's no longer guesswork. And another example I will give you in a live scenario is, so you have a pool of 1 million possible customers, right? And you are told that you can only make a single stab into this 1 million pool. The first stab you are going to make, you are going to take 100,000 and you will not get another chance to make a second stab. Now, what is going to inform your decision? Are you just going to randomly put in your hand there and take 100,000. Yeah, that could work. But then imagine you have data about the behavior of some customers that you already have, and you have data about behaviors of all these 1 million. You can do better. You can decide to find out of your customers who have some behaviors similar to, so you can find out of the 1 million people who have the same behaviors as the customers you already have and are doing well. Those are the type of customers you also want to get, so that you are no longer guessing about what's going to happen. You're now predicting your future and taking it into your hands. That single stab you have into that 1 million can now be an informed stab. It's not just a blind toss of the dice. You're actually going for where your value is. So this is one way data is changing almost, almost every enterprise's way of looking at their prospects and what they are going to do. Okay, so we are getting much safer today. Okay, and it says luckily. Now, if you're in Nigeria, you might think that this is far-fetched, but think about it. All the data we have about people, the country is now driving towards NIN. Now, this is how we get much safer. We can out who is where, and when something happens that is a threat to the collective safety of every one of us, we can actually see who that is, and we can go after them. We can even take proactive measures and look at some behaviors by some people that match closely to some behaviors we know of people who are a threat to the society. Okay, so that is making our safety much better, and we can also be proactive about things we do about safety. Even if we're not doing it today, those capacities are around, and that is one of the reasons why young people, I think, and tech people in Nigeria are getting frustrated, because we have tools to do this, and we should be able to get them done. So apart from being able to predict the future, we can be much safer with data, because we can know who is doing what, and these things are going to make us safer. Now, on the third point, it says we make the world a better place. So, I mean, collectively, if we're able to do all these things around data, but that has to be data that we have. And that's why it's important to put these things together and, have an organized way of reaching it. Okay. I still give an example with Nigeria. In trying to keep data about its citizens, we have multiplied databases. Okay. We have NIN, we have BVN, we have NIMC. I mean, there are a number of them, but this should be a central place where we can all depend on and know that we have the appropriate data that we need. And once we do this, our security, our safety, and so many other things that revolves around our knowledge of what we have and what we don't have is going to improve our life generally. So it's 7:20 now, and I will leave us to check the other link. And yeah, I hope Areza is going to share it with us. So those are the 3 points I wanted to make about how data is helping us do so many things that we are doing today, either individually as we make our decisions based on what we are seeing, taking in, and processing, or as enterprises on the data that we keep, helping us make better sales, make better predictions, and take products that is going to satisfy our customers. Areza.
Thank you very much, Mr. Pascal. That was really an insightful one on how data is changing. Sorry, I'll correct myself. How data has changed the world and is still changing the world. So we'll go straight to Mr. Zion Ibowe. Good evening, sir. Confirm you can hear me. Trying to get a slide.
Yes, good evening. I can hear you.
Okay, good evening. I'm opening the slide now, so I'll share that right away. Okay, I think we're here. All right, so he's going to be leading us on a session on how artificial intelligence is impacting industries. And after that, we'll go straight into questions and answers. So do well to note your questions already. Okay, can you see my screen?
Yes, I can. Okay. Thank you very much, Arinze, for this for moderating this session. You're doing a very good job. And then I have to also specially recognize the speaker before me for breaking down some points. So my own focus here tonight is how AI is impacting industries. So I hope those of us in the meeting can hear me. I would like to hear your voices just to be sure I'm talking to real people.
Yes, we can hear you. Good evening.
Okay, good evening. All right, so my focus today, I wanted to prepare a very exhaustive slide, but because of time, so I will just look at these four key areas. Part one, the science. Part two, the technology. Part three, AI engineering, and then part four, AI careers. The truth is, the time, 15 minutes is a really small time to exhaust these things. So what we'll just be doing is sketchy, and then hopefully in subsequent meetings, we'll have more time to elaborate on them. All right, so let's go to the first part, the science. Um, First of all, we have to understand that AI is a branch of computer science, so it's majorly an academic field, or it's primarily an academic field. And then what we do is that we take that science and then we turn it into technology. So technology means that we can apply science into everyday, scenarios, including business, industries, and so on and so forth. Then the engineering part deals with, how do we design AI models? How do we implement AI systems? How do we build systems, implement them in processes and systems and all that? Okay, so in under part one in science, Mr. Renze, please can you just move to the next page? I will just stop there so that I'll just stop at this page and then I will just explain the rest. So um, for AI as a science, we have these various subdomains, subdivisions. We have problem solving, knowledge representation, planning and scheduling, probabilistic reasoning, intelligent agents, computer vision, natural language processing, and then machine learning. I know most of us are more familiar with machine learning. Most people who have heard of AI are most familiar with machine learning, but there are also other key aspects of AI. Problem solving just deals with, um, enabling computers or giving computers the ability to solve problems like humans would do. All right. But the advantage of computer systems carrying out those tasks is that with AI now, they can carry out repetitive tasks, they can iterate, and they can process faster than a human would. So computer would do that seem natural to us. Things like speaking, seeing, listening, and all of those things, blinking our eyes, you will think those tasks are very simple because they feel automatic and intuitive, all right? But they are actually very complex tasks. The way you're going to know that they're complex tasks is when you want computer systems to carry out those tasks. The computer systems cannot really do those things. Computers are very good at doing things that we cannot do naturally or that we find very hard to do. But the things that we find easy to do, computers find it very hard to do. So the goal of AI, one of the major goals of AI is to enable computer systems have these abilities to function the way humans would, but then with the advantage of being able to automate those tasks, faster and probably better. Okay, so I will just the first 5 points here. I will just skip them and then I will focus more on computer vision, natural language processing, and machine learning. After which we then go into the technology aspect. So in computer vision, we're dealing essentially with giving AI, enabling AI to, enabling computer systems to carry out visual tasks. All right, to automate the human visual system, to be able to process things like digital images and videos. In computer vision, problems that we're dealing with are problems like object detection, image recognition, scene understanding. That's given a particular scene, probably a robbery scene or any kind of scene. Can we? Sorry, excuse me. So any kind of scene, can a computer system understand, and interpret what is going on there? Okay, so those are some of the tasks for computer vision. So And this task is not something that is quite straightforward for computer systems. So we have to allow them to, learn from data and to be able to, build, organize various portions of the data and learn the way humans learn and then carry out these tasks automatically. Then natural language processing, majorly what we're trying to do here is to give computer systems the ability to understand and interpret natural language data, majorly with the goal of enhancing human-computer interaction. So that if you talk to a computer system, the computer system can talk back to you, or if you send a text, you write into a computer system, it can understand your input, understand the context, understand syntax, and all those kind of things, and be able to generate sensible language and communicate back to you. So if a computer system can maintain a consistent flow of communication with a human, all right, we see that that computer system has natural language processing capabilities. So normally this aspect of AI is a really popular and ongoing area, and we just shorten it to NLP. Okay, then machine learning is the very popular one. Machine learning, basically, we want computer systems to learn from past experiences, that is to learn from data, all right, and to be able to make predictions, or to be able to understand patterns and trends in data. So given a particular piece of data, we want computer system to learn from that data, to understand what what could have caused whatever happened in the past, and to be able to predict the next course of action, or to be able to predict the future. So that's the major task of machine learning. So in machine learning, what we do is that we run algorithms on data. The algorithms are the procedures or the processes, all right, a step-by-step procedure for the learning task. And then when we run the algorithms on the data, what's the output of that entire process is a model. All right, so we get a model out of the entire process. That model now is able to solve problems intelligently, is able to predict future trends and all that. So in machine learning, we typically have three major areas. We have supervised learning, we have unsupervised learning, we have reinforcement learning, and then we now have deep learning too. So in supervised learning, just like you think about a child that you want to teach, all right? So what you do is that maybe you want to teach your child alphabet. So you take the notebook A to Z. So you start telling the child A for apple. The child learns that A for apple, B for ball, C for cat. All right. So what you are essentially doing is that you're providing answers to the child. So the child is learning from the answers. So you guys providing the answer, you are the supervisor. All right. And then the answers you're providing for the child to learn from are called labels. Using machine learning terminology, we call that labels. So the child learns from those labels, all right, so that when a child sees apple, it knows what it is, all right. So it sees a green colored fruit, and then it's able to assign a label to that fruit, all right. It sees a spherical object, and it's able to identify correctly that it's a ball, all right. So it is assigning labels to various classes or various objects, because it has already learned from past data where labels are supplied. That is supervised learning. Now imagine a situation where you leave the child, all right, maybe in a room, and you just go out, and then the child begins to explore the environment, no teacher to provide answers, okay? The child begins to learn about the environment and all that. So maybe the child wants to, maybe the child is crawling and wants to move out of the room, all right? There's no way it would know automatically that there's a door or there's anything like a wall, okay? But when it maybe crashes on the wall, it learns that, okay, this is a barrier, so I'm not supposed to cross this, okay? So it is learning by itself, not by being given answers, but it is just learning by understanding the patterns in that environment, all right? So that's unsupervised learning. The computer system is able to, without having any answers or any labels that identifies, okay, this one is this and this one is that, it just goes into the entire data, and by itself, it picks out associations, it picks out patterns, it studies trends, Okay, what happened on this day? Why was this like this and this like this? Okay, this and this and this are similar. So probably they should be clustered in a particular way. All right. So all those various ways of finding associations in data, patterns, and all that. That's called unsupervised learning. All right. Then in reinforcement learning, the task here is to learn by doing. That is, this scenario is where a computer system is made to learn by interacting with a particular environment, probably a dynamic or a changing environment, with the goal of maximizing a particular accumulated reward. All right. So let me just give an example in this particular case. Because one thing about reinforcement learning is that it doesn't receive as much hype and um, as much noise as supervised learning and unsupervised learning gets, but it is in fact one of the those areas you can really call the core part of artificial intelligence. So in reinforcement learning, if I will give an example, you imagine where you are trying to teach a child how to play chess. Okay, if you are familiar with chess, you know that in chess, the first thing you want to do when you're teaching someone is you want the person to first of all know the moves. What are the moves? Okay, how does this pawn move? How does the bishop move? How does the knight move? The, the moves are the first things to learn. Then when the person knows the moves, the next thing you want to teach the person is the tactics. All right. What happens when this person attacks me like this? How do I open my pieces? If my opponent plays like this, how do I respond? Those are tactics. All right, then after the tactics, the next thing you want to teach the person is strategy. Strategy is more um, 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 sort of requires a lot of deep thinking and strategizing, of course, from the word strategy. So now imagine a scenario where you are not going to provide all those things for the child. Right? Instead, you tell the child, make your move. Okay, if you get the correct move, I give you ice cream. If you make the wrong move, I give you abo. I know children they hate abo, so a child will want to as much as possible get ice cream. So the more the correct moves the child makes, the more the ice cream the child gets. And if the child makes wrong moves, the child gets abo. So what the child wants to do is to maximize how much ice cream he can collect at the end of the day. Okay, so he makes the first move. The first move has a 50-50 chance of being right or wrong. Okay, but the child doesn't know anything prior to that. So the child just has to make a move to learn. After making that move, if you say it's correct, he already knows that, okay, this move is the correct one. So it sticks next time. And if it's the wrong one, it knows that for this particular piece, I'm not to move like this. Okay, so gradually the child is beginning to learn by trial and error, through doing through actually doing or solving the problem. Okay, so unlike unsupervised learning is the child is interacting in the environment to understand the environment, and then later the child can solve problems based on that knowledge. But in this case, the child is already, in the case of reinforcement learning, the child is already solving the problem. The child is learning by actually solving the problem. So reinforcement learning has had some brilliant applications over the past few years in the area of games. For example, I don't know if some of us are aware of AlphaZero, the AI system, the AI engine that beats the world's best champion in chess. So games in particular, some of the major applications of reinforcement learning. But beyond just casual games, in economics, business systems, and all of that, we apply reinforcement learning to 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 understand business competitions, to position businesses for competitive advantage. Right? If some of us are familiar with we might be familiar with terms in economics like game theory. Right? Game theory deals with how businesses and corporations, how they compete. Okay, so when AI is applied to game theory, when reinforcement learning is applied to game theory, we have a very powerful solution, a very powerful tool for enhancing business competitions and positioning yourself. So all these things have various advantages, not only in casual games, but also in the business world. All right. So the technology aspect, I'm moving to part 2 now, AI, the technology. in the technology aspect, we are looking at, okay, what impact does AI have on industries? Um, how is it AI really changing things? How is AI a game changer in the world today? So there are some scenarios that we can look at. We can talk about fraud detection, where AI is able to not only detect fraud but prevent it from happening. Okay, most people have a redundant approach to fighting crime and stopping fraud. The conventional approach, the conventional approach mostly is when the fraud has taken place, we arrest the culprit and then we try and see if it is possible to recover, the funds and money that is lost and all of that. Okay, but what if that is never recovered? All right, what if that is never recovered? The best scenario now, the best case, the best way to handle this kind of thing is stop the fraud before it even happens. And how do you do that? AI is what's one of the tools that you can use to actually accomplish that. All right. So before the fraud takes place, you stop it right away. And how do you do this? First of all, AI draws on a lot of data. AI requires a lot of data to AI requires a lot of data to function. So we have already gotten past data about fraudulent transactions and all of that. So AI systems are able to understand the trends in that data, and then when they look at the data, they're able to spot when there's a new scenario, similar scenarios of fraud, and so they're able to stop it before it takes place. In that case, you can arrest the culprit before he even does any fraudulent